So I'm just teach the basic ideas of the programming and some simple syntax, because there's a lot more than this that can go into the robot. But if you're just trying to get a simple robot just up and driving or something, this is exactly what you need. So there are 3 main programming languages you can use to actually program an FRC robot: C++, Java, and LabVIEW. LabVIEW is kind of like Scratch in a way. Don't use it, it's terrible. Java and C++, both of them are pretty good, but they're both pretty well known. They're used in the industry. C++ will actually run a little bit faster than Java, but Java is also just more well known and more easy to read and program. So, and we've just written all our robots in Java because that's what our programmers have known. So the IDE we use, so just basically the application that we use to write it all, is Visual Studio Code. That's something you kind of have to do because they'll provide like a download link, not just to this application, but to their whole library. A library is just basically how you program all that stuff. I'll try and get into more depth into that in a minute here. The FRC library, oh wait, I should just go over it now, is WPILib. You can call it WPILib. That's what I call it. That has all, WPILib, I call it WPILib.
Or just your Polytechnic Institute library.
WPILib. But that has all the resources of the actual programming. So like, I don't want to go into the depth, but basically a library is how you program code in a way. Because like you couldn't just write letters and say like, motor turn left, drive forward, climb. You can't just say that. It has to be written out a very specific way, and that's what the library does. The library is just like a dictionary. That's why it's called library. I'm an idiot. That's why it's called the library. It's because it's a dictionary that provides information for everything, every aspect of the robot, whether that's a motor controller, that's the PDP, or a different type of motor controller, whatever you work with. And then GitHub, think of it kind of like as Google Drive. It's just like a backup with everything on the cloud. So all our code will actually be saved onto a computer, but we want to have a backup in case anything goes wrong, or if we want other people working on it.
GitHub's like Google Drive, but more public, because everybody can access what you're doing.
Yeah, but you can make it private and stuff too. Okay, so the basic file format. There's only really one file you have to deal with when you're programming robots, the FRC robot. There is other ways to program the robot. This is the way we've always done. So at the very top, the package right there, that's just the file location. That's just telling the robot, hey, all your robot code is in this file. Look at this. Resource imports, that's when you're calling things from the library. That's when you say, oh, how do I program this motor controller? Or how do I use the PDP properly? It'll grab all that information so you can write the code for it. The class header, that basically says, okay, all your actual robot code is in this part of the file. And these main functions. So if you guys notice, like there's different parts of the competition. There's like the autonomous period. There's also the Tele-Op period where you manually control it. There's also 2 other periods, only one of them is on here, that you can use on your own. So disable is an example of this. What code do you want to be running when the robot's on, but not doing anything? That could be like checking sensors, updating sensor values, or making sure the compressor's off because you don't want it working while people are working on it. Making sure all the motors are turned off. Tele-Op is when you're going to be putting all your code that you actually want to control the robot during that time. I said that weird. So anything that you're if you're using like a joystick, or if you're like pressing a button, you want all that kind of code to kind of be in there. Then the autonomous section, that's where you want all your auto code. You want to tell the robot to drive itself forward. You want it to power a shooter or whatever you want. And the 4th one that isn't on here is just called robot init and robot periodic. It's basically going to be called in no matter what mode you're in. So if you're in test mode, if you're in Tele-Op mode, oh, that was the 5th mode, sorry. There's a 5th mode called test mode. It's basically you press on the computer, I want a test code, and it'll run whatever you put in that test section.
So like it like spin all the motors for 2 seconds.
Something like that, yeah.
Or you could make all the pistons retract in and out to make sure they work.
Exactly, like our test mode this year was our calibration sequence. That way we could reset the climb all the way down to the bottom, put our arms all the way back up. Oh, and one more quick thing. If you notice that there's 2 things per section, init and periodic, if you guys look at these comments right here, basically it just says, this first function is only going to be called once, and the next function is going to be repeated the whole time. So like let's say you want to boot up a motor, or you want to make sure your motors are all off, or you want to reset a sensor, you would just put that in the initialization section, just so you can make sure like, okay, the sensor is reading 0 now, and then during periodic, it'll actually update it to read whatever it is. Because you don't want to be constantly resetting the sensor over and over again. That's useless to you. So instantiation is basically when you create all your objects. An object in programming, you can just think of it as an object in real life. It's an actual thing. It's a motor controller. It's a joystick. It's a PDP. It's an actual software representation of whatever you're working with. And that's what you import from those libraries. So there's the first part of it is your visibility. If you want to be able to access it from other files and stuff, you don't really have to worry about that. Everything here should be private. I don't know why they say public. Oh, it's because I ripped this off like a old code that we had from our previous programmer. He didn't 100% know what he was doing.
Who was he?
What?
Who was the old programmer?
You guys know him. He graduated. So
He did pretty good though.
he did good. He got it working, which is all that matters. If it works, it works.
He didn't even know.
Okay. The second part of it is the variable type. It's whatever type of object you're trying to make. So like if you want to make a cup, you need a cup holder. If you want to make a car, you want a garage to store the car in. It's basically that idea. You want to have that set type stored so it knows what it's actually doing. Variable name, that's whatever you want to call it. So if you want this to be left drivetrain motor, right drivetrain motor, claw arm motor, or claw motor, arm motor, whatever you want. The constructor actually generates that object. So this first part only makes a variable and it saves space on the RoboRio in memory for it. The second part will actually make whatever it is, and it'll actually say, okay, you are going to be this type of motor controller or this type of joystick. And then if you notice here, most of the code will have parameters. A parameter is just basically input to provide a very detailed specification. Like a motor will ask for a port number or a CAN ID. So if you want to control the arm motor, you need to say, okay, the arm motor is going to be on port 5. So I want to just be controlling the one on port 5. Or the joystick, that's the one that's going to be plugged into the USB slot 0. Look at 0 for this joystick. Or whatever you're looking for, depending on what you're plugging in. Data members, so this is just like, this is typically values you're going to be using during a program. So like it has the same idea, there's the variable type. There's 3 main types that you will use with programming the robot. Is an int, a double, and a boolean. An int stands for integer, pretty straightforward. It's an integer, it's a whole number. A double is basically decimal, is a number, but you can use decimals with it. And then a boolean is true or false. The variable name, same idea. You want to be able to store that value in a name. You don't want just random numbers floating around. You want to be able to access it. So you just give it whatever name you want. Then on the other side of the equal sign, you can assign the value of that variable. So I want the stick to be on the port 1 of it. Or I'm trying to think of another good example, like setting the power, like setting a constant power. You can also set that, okay, I only want it to be running at 50% at all times. And rather than write out 50% all the time, you can just write the variable. Okay, methods. So in the objects that you make, that I referenced here, they'll have methods attached to them. A method is basically a function that gets you data from the object. So like let's say we have a joystick. So right here, it's called button, but it's a specific, like you can think of it as like an actual physical button joystick. It gets the value of the button. And it depending on what method you're using, it's gonna give you different values. If it's an integer, if it's a double, if it's a boolean. In this example, it gives you a boolean. It'll get like true, this button is being pressed, that's true. When you let go of the button, it's gonna be false because it's not being pressed. And that will be stored in the boolean variable, write 1, write 2, whatever you're trying to write. And then you can also set parameters on those objects. So this probably should have been on the object section, not the data member section. But in these objects, you can set values, not just get data, but give it data. So you want to set the motor to be at a certain speed or set it to a specific voltage. Depending on what you're trying to do with it, there's different methods. That's the point of the library, is you look through it and see what methods you want to use for it. Okay, logic. This is how a lot of our control actually works. Or if, and else blocks. So an if statement is basically, if this condition is true, run this code. If that code isn't working, else if this condition is true, run this code. Else is if none of this is true, just default to this section of code. So in this example, you're getting the raw axis of your joystick. You're getting the value of your joystick. A typical joystick will range in values from -1 all the way to 1, with decimals in between. It stores it in the variable right x. So if right x is less than 0, meaning that it's a negative value, meaning the joystick is being pulled back, do whatever you want there. Run this code. Typically that's like drive backwards. If it's reading a value less than 5, pretend the joystick reads a value from -100 to 100. Let's say you were just pulling forward just slightly, run this section of code. Otherwise, run the third section of code. Oh, that's honestly basically it for programming. People see programming as like this very scary and they have no idea what you're supposed to do. They see all these random letters sometimes. But that's also part of why Java is preferable as opposed to C++ or LabVIEW, is because it's a little more readable. You can kind of see like, oh, set the voltage of the left flywheel motor to this value. And all that logic stuff like saying, oh, how are you controlling it, or how is it running autonomous code by itself? It sets a timer and just runs the motor for a certain amount of time. It's pretty straightforward. If the time is less than this timer, keep running this code, so on and so forth. And here are additional examples. So on the left here is our GitHub page. So if you actually want to look at all the robot code, you can hop on there and see all of our backups. And on the right side is the documentation. Documentation not only has stuff about mechanical things, it has stuff about the programming, like the libraries. It has information on examples of code of how to program something. Okay, do you guys have